Hello to the people. We'll be starting in, I don't know, 10, 15 minutes. I need to have my pre-session protein. I need to make some tea, and then we'll go. And I need to try to make sure see, this thing, I guess, used to have a background or something. Maybe I used the Weissman score background. What if I turn off the Weissman score? And then I just have this. And then I make the Weissman score bigger. Or smaller. Like, it's so stupid. It snaps. Like, it snaps to the rectangle of the camera, not including the... All right, so we're going to go there. And we're going to go there. Okay, except let's just bring that down. Let's bring that down, and then we'll put the camera in front. Okay, that's technology. That's technology right there. Switch to the Cyberpink overlay. Maybe someday. You know, for a program that's like 10 years old, it's surprisingly hard to get OBS to do reasonable things. So we'll be starting in a little bit. Not yet. Not yet. Remember those 2 days when people cared about Cyberpunk? You know, it sure seemed like they cared really a lot. They were asking me every 5 minutes about Cyberpunk. It was crazy. It was crazy. I got my protein. I got all these different kinds of snacks. I got chocolate. Going all out here. I got peanut butter M&Ms. It's crazy. We're not going to eat them all at once. How long? How long do I say? Are we at 3 hours? Is that what it's supposed to be? Yep. What's my advice for people who rewrite their code a lot? Make sure you're actually rewriting it to be better every time and not just different. Make sure it's actually better. Make sure you have a forward direction. You keep rewriting the whole system. Well, why do you keep rewriting the whole system? Is it because there's something you don't understand about what you want to do? Or is it because you don't want to do the rest of the job? Okay. I'm going to make some tea, and then it'll be time to start. Pollenbarian. I mean, the thing about chess moves is people get the idea to put those in games a lot, but that doesn't mean it's good. We'll give it a try though. Look at that, guys. I'm going to have so many more Steam points. All right. Wow. Hello, everybody. We're about to start an intensive work session. There's no about page. It's down there somewhere. It's on, the description is there somewhere. This is on the compiler. I feel like if I were a high production value pro streamer, I would have like a countdown clock, but it's just my iPhone. When did I become Twitch partner? Like 5 years ago. I don't even know. Okay. So we're going to do 3 hours of as intense as I can manage for those 3 hours. We're going to do an hour 30 and then a 5-minute break and then another hour 30. It's too bad I'm not starting at exactly 11, but the tea's probably not going to be done. Will sub-only streams be regular? Yes. Yes. Okay, the tea is now being steeped, and when the tea is done being steeped, we will go. Maybe we will go before 05. I don't know. Almost ready. We're starting in 4 minutes is what time it is. Just need the tea to finish, and we will have tea power. All right, let me explain generally what the goal is going to be while we're waiting the last couple minutes. In this language, we have this quick Lambda construct. Actually, I hadn't even noticed that we have this. Let me write this down. Anyway, where you write, the variable and the expression kind of like C# or something, it makes it really simple to pass a function that, that does not have the type baked in and all that, yet still operate within a strongly typed system, right? So this is a shorthand for something that eventually gets fully compiled down to systems level executable code, right? And so the thing is that the way we do this process, back when I did it, I knew it was a little bit shoddy and a little bit fraught with peril, and once in a while it causes problems. So we're just going to change the way that works. I have a vague idea about what I'm going to change it to, but to be honest, I don't totally know. So it's going to be, I'm a little bit winging it and seeing what happens. So that is the plan. They don't have captures currently. That is a to be added feature. All right, let me get the tea going. Maybe I could have let that steep longer, but you know, the value isn't going to make itself. Wow, I don't know why I'm losing my voice. Again, I guess I'm dying of COVID, as happens every so often on this stream. All right. Too much pizza. All right, I'm going to close chat now. I am not seeing what you guys do, so behave. And starting the timer. So we had a thing that was failing. Which will be a good test case. It may not actually be the best test case, but it was that. So this will currently not work. Boom. Yeah, that said, maybe we want to, because we're going to take it down to the basics. So do we have a quick? We don't. Okay. How about features? So we're going to look in tests, features. We had like a quick Lambda demo at some point. Quick Lambda outer local. Oh, that's a fails. That's no good. Okay, you know what? Screw it. We're just going to make... We're just going to have a simple example and... let's put this in the other order. We're going to have an array and a function, and we're going to say so like that, and we're going to have square is a quick lambda that maps x to x times x, right? And we're going to say results is map of 1, 2, 3, 4, 5 through square. Results is whatever. All right. What is going on? Okay, this has something to do with overload resolution, this new bug. So we're just going to call it my map. So that we don't have to, because that's the bug that we're working to solve. Wow, what? This is like not even working at all. How did we get this far where this would frickin' fail all the time? I don't understand how we ship this many betas. So this is a type we're matching against. Oh, never mind. Okay. So this assertion is actually just confusing the issue. What was going on is what I was doing was actually illegal because we need to know what T is. It's just we're also asserting in the debug compiler, which we also shouldn't do. So I'm going to write that down on the list. Assert in debug on map example. So this one actually will work if I don't. So I just have to say what the type of this array is. So for example, it's U32s, right? There we go. Okay. So we're mapping square, right? Let's actually even change this back, right? That's probably, there we go. So, you know, this is what the functional language people will tell you all day is great. And, you know, we just do that. So, actually, you have to add some monads and continuations to that, but, you know, it is what it is. So this, we're paring down to this test case. This is like how we know that the basic functionality of this thing actually works. So now let's destroy it. Okay. So in the old version, we make a type of and point it at the block and stuff, and that's no good. We're not going to do any of this stuff. This is a no check-in. I'm not sure why I'm making a return statement. Anyway, we'll figure that out. So we need to make a declaration. It's true. Maybe this, and we're going to add it to the returns block. So basically, when you write this thing, we're desugaring it into a procedure. And so we're like making a return declaration and stuff, but the way that that was being done was not good at all. So we still need to make a return declaration, but we're going to bind it to something else. We're going to bind it to the same kind of thing. We're going to make a variable called quick lambda return. And I forget what the arguments are to this. Okay. So we are gonna make a declaration with this identifier. Actually, we don't need that. Right. Okay. Let's be consistent with the other function. Okay, so we're making what's essentially a type variable. This is what the implementation looks like, and Yeah. Actually, we should not. Maybe we don't need this. Okay. We don't want this to map to any of the user's variable. Okay. So we add that to the constants block. And then we need to make another declaration. Wait. Oh. I guess add to constants block does that. And now we'll make the declaration. We add this instantiation. And this, instead of being a type of, is actually, you know what? Let's keep that expr. Let's make this expr. This, instead of being a type of, is just the t. Yes. So we're just saying, instead of saying it's a type of this thing, that was what was causing the problems before, we're saying it's a return declaration. So we have completely destroyed everything. It probably won't even compile. Nothing will work at this point. I've completely destroyed the compiler. So like, yeah. Like, who even knows what's going on there? So now okay, the question is, how far are we getting? Can I do this as long as I don't use it yet? Or is that even busted? That is even busted. Okay, that's fine though. We need a flag probably on Lambda that says that we are a quick Lambda. Okay. Let's find a free flag. 248124812. Quick. It's so quick. Is 4. All right. I should clean up the formatting of that sometime. Lambda is quick. And so when we infer it, we need to decide when to do various things. So we need to know that there's no point in inferring the body. Like what here we're somehow Oh, you know what? Oh, that's the check we were talking about. Okay, actually, let's do this. We'll fix that in post. Okay. Well, that's great. This won't work though. Results are all 0 though. That's great. Okay, when we flatten this, there's a 2 steps to the infer process. We go and we flatten it, and then there's a step where we actually infer all the sub-expressions. And I think when we flatten it, we just want... I think we just want a totally separate infer routine. So when we flatten a lambda, we do all these. If it's a quick lambda, do all these. This is meaningless. Now get inferred via a separate process. When we polymorph, we need to remove this flag, probably. Okay, so we need 2 things. We need to modify the infer, and then we need to go to polymorph. And okay. Oh, if there are no argument types remaining. There definitely are arguments remaining. I was going to do something stupid. Actually, no. This is not the right... We don't need to do this, I don't think. Okay. could even move that out. Okay. Just like I said, I don't know exactly how I'm going to do this. I'm kind of winging it. But it'll end up better than what we had for sure. All right, so when we come to infer a lambda, we do check function header. That's going to check the arguments and returns. So let's just go edit that. Whoops. What? Just not even worry about it. Okay. Check function header. So lambda. So here we check the arguments. That is fine. That is fine. Returns. Okay. If it's a quick lambda, we do one thing, else we do another thing. Okay. So, okay. We actually need to check a lot of stuff here because the user could like bake shit. Push and infer the body block, then come back and do the header. Yes, okay. Okay. So we find if there's only one. Okay, so if gonna put some blocky block here. Else if last unbound constant will do something. And then if should infer return, we do something else. We go set inferred type. Okay. And then what's down here? Yeah, that's just a bunch of other checking. That's probably fine. Okay, so if it's a return, all right. So here we got to go declaration return decal is null if returns block members dot count is equal to 1. Return decal equals this. Actually, let's just do this. Else more than one return declaration. This is illegal. Okay. This quick Lambda has, which you can't do this through the parser, but you could modify something via the syntax tree and pass that in. Probably. Maybe. I mean, we might make quick Lambda be a different syntax tree node that prevents that at some point. Okay. So if we should infer the return, what happens? Well, okay, hold on. Let's worry about that later. Actually, we need this up here. Because okay. Because we're going to use that. And then we do that. Okay, so if none unbound constants is greater than 1, should infer return. Okay. If it's the last unbound, if there is an unbound constant, this might not actually be the one belonging to the return block in case the user did something really weird with bakes, so we check it. So how did we set this up in the parser? It's the type inst and again, we're going to complain here, report error. This quick Lambda has a malformed return declaration. We can't infer it. Return false. Okay. So this auto expr equals this. All right. Type is asked ident. Else, right? We're going to report another error. Let's just do this. Okay. So we don't have to, right? We're going to do something and then say handled equals true. So if we don't get all the way down into here, we'll trip that. Okay, so what? Well, oh. You know what? You know what? We want this identifier to get resolved via normal processes, I guess. which means that we would flatten it back in flatten, and we wouldn't make the quick lambda flatten different at all. Right. What we would do is just change the type. So we're going to check if that is equal to our last unbound constant. If we find this, we're just going to cowabunga it, right? This is the cowabunga technique. It's a very advanced programming technique. Actually, last unbound constant. And you know what? We'll just say handled equals true if we get here. We might, like, as long as we find something. Okay. Is unbound constants block binding? Yeah, all right. Dude, scope entry was my worst mistake in the whole compiler because we don't even use it. Okay. Okay. We got our cowabunga. So all of this appears to have worked so far, which is great. Okay, so we got our return declaration. Oh, well, we're not, okay. Let's actually make sure we get all the way down to here. Let's put no check-ins on this. An important part of the cowabunga technique is to put no check-ins. All right. Yes. Okay, so we got to the point. What this should infer return means is like, okay, we know what all the arguments are to this quick lambda. It got polymorphed. So now we want to know what the type of the body is, so that we can infer that. So I think what we need to do here when we call check function header, okay. So I think this is all fine. So now we need to do this thing where we kick off and infer on, like, this function is called check function header, but like it's actually doing more than that, right? I can imagine wanting to increase robustness later by factoring this into multiple parts. But here's what we're going to do. We have push and flatten. I said push and infer here. It's called push and flatten. So we're going to call this we actually want to say that this block has gone live. Oh, that'll make it go live. Probably. All right. Hopefully that push and flatten actually works. So then we return false saying that we did this, but we need a way to like state machine switch off of this. Now, what I'm actually going to do also is down here, we're actually just going to fall through to the regular infer for this. This is just error checking and stuff. Okay, so I need to record on this procedure somehow the fact that we kicked this off. I don't actually want to put it in the Lambda flags or in the defen flags. I don't know why I put these far apart. Maybe I was worried about false sharing or something. We're just going to add more flags. Okay. Lambda status, inferred quick lambda body. Great. Okay. So when we get here, if we're a quick lambda, we're going to go if this, else all this. Or status flags. All right. Okay. I almost checked the wrong flags, guys. If this, then okay, this is a weird one too, because I think when we parse it, we make a lone expression inside the thinger. Let's see. We have expr. I think we literally make this return statement. I think we do that. I think actually this part looks mostly the same, except we don't do this, right? We're doing a more involved thing instead of that. This extra like 50 lines of code that we've been typing, which is fine when it's more robust and better. So, yeah, I guess we just desugar this into a return statement. Okay, so we're actually just going to push and infer that. Now, of course, that could be arbitrarily it's like we do have this mechanism where we can check the body. Like I did this push and flatten thing, but we actually could tell the body to queue. And sleep on that. I don't know. Anyway, we'll think about that. Report info Lambda Cowabunga, we're back, baby. Okay, so if we see that, that's pretty good. And okay, here's what we're going to do. We're going to look for our one return statement here, and we're also going to complain if we don't see it. So asked if we don't find this, we'll say this quick lambda is malformed, has a malformed body. Body shaming. Has a malformed body. We could not find its return statement. Return false. Okay. If lambda blocks state mints.count is equal to 1. Lambda block statements sub 0 if expert type is equal to ask return. Ask return is static. Cast ask return expert. All right. So that's how we find that. And then now down, we find that in both phases, both the pre-phase and the post-phase here, which means down here, instead of lambda block, right, we're just going to do asked return. Okay. See how we're doing there. 682. Wait, what? And asked. Did I accidentally type out? Oh. Here we go. All right. Quick Lambda has a malformed body. I knew I would get body shamed. All right, let's see what happens. Malfoy body. It's like a Harry Potter situation. Are we even compiling the right thing? What is taking so long? Okay. Expert. What is expert? If it's asked return, okay. It's not body shaming me. So where does the body shaming come from? Oh, here. Oh, because when we copy, we're not copying the body for some reason. Okay, yes. Here is the Sag. Here is the Sag. When we did that weird type of hack in the parser, one of the things that was doing for us was it was causing the body to get copied. Like, we need to copy that whole body anytime we try to polymorph this thing, because that's how we know the type of the thing, right? It was getting copied because we were sort of linking it through that type of expression that we commented out. So we actually needed to do this. Brutus, we ain't new to this. All right, so whoops. Cannot have a body after a type directive. That's an interesting error. Maybe that has something to do with the way that I'm copying it now. What is going on? Okay, 1250. Okay. Okay, we cowabungaed, we said we should infer the return, and then we're back, baby. But we still haven't defined this variable. Okay. So we're back, and we're badder than ever. So okay, this return needs to have we'll also complain about Draco Malfoy here. We'll say Draco Malfoy, the return statement doesn't have, the internally generated return statement doesn't have a return value. Okay. This should never be a problem. And then we say, what do we say? We say my tea is getting cold, but we still have 40 minutes before the break. I'm going to have to go with cold tea. It's like iced tea. Okay, so it's got a malformed body. What do? We get the type and we define both the constants block okay, actually, all this stuff we want to do again. It's a little bit redundant to do this computation. Okay. It's a little redundant to do this computation twice instead of storing it, but hey, it's not going to take long, and let's not waste the memory, add complexity. That said, we have the potential complexity of this answer coming out different each time. Okay, so here we go. So we get the return decal. Here. So we get the return declaration. We say, etc. Okay, so if we already inferred the body, use the resulting type to set the return declarations type. Otherwise, what? Otherwise, kick off the infer of the body. Okay, so we get the return type. Let's even print it. Let's have a little victory moment here. The return type is okay. We're making a lot of cowabunga progress here. The return type is U32. That is correct. So now, we need to specify that variable. How do we have a way? I could just poke it, but I think we have a function that we call. No, we actually add to constants block. Bind constants block entry. Is that an ast? Set the expression, we set it to constant, we set the type, we clear. I think, I don't think we need that. I'm going to write it down though. I think that type inst is not used anymore. Okay. All right. So we're just going to use this. We're going to say bind constants block entry. Interp return decal to defen, and we're gonna set inferred type. Wait, that's not the. No, that's the wrong. We want to bind constants block entry of last unbound constant. Okay. Well, we didn't like that. Oh, wait, what? Last unbound constant was not set? Remember what I said about getting a different result back each time? So we said should infer return. Okay, let's print. Let's use %p because we're sophisticated. Let's make sure these are all for the same dude. Oh, %p was a mistake. So 550 somehow. After we do should infer return, num unbound constants is getting set to 0. Or, you know, how's that happening? Oh, is it, we're going to have to check. It's okay. I know what's happening. This is banana nut balls, guys. The way that we do polymorphism is the type checker. When you match a polymorph variable versus another expression, right? It'll give you the binding. Now, I don't know why it would be. We should check how and why it's modifying the binding. But anyway, the thing that is happening here that I did not think of is that we are now inferring the body. And the problem is, well, maybe it's not it shouldn't have been a problem. Maybe we have this return statement that we desugared into that's in the body, right? And that return statement says, hey, return this one expression. Now, normally when you type check a return statement, it's after the header of the procedure exists. So you check the type that you're returning against the corresponding return type in the procedure header. Here, that is not the case. We actually don't want to check against the header because A, it's meaningless, but B, I feel like it's somehow causing us to polymorph that variable away. I don't exactly know how that should be possible, but it seems to be. So let's take a look at that. What I'm going to do is well, let's look at a few things. What are the criteria for is unbound? We could set a breakpoint because it's still 1 when we go off and infer our body. So we could see how it comes to be 0. So it's just got an expression, I guess, right? So we could set a data breakpoint on the expression. But also, I could visually inspect it here. So when we get here, where are we? Let's get rid of these. So this is going to be 0, right? 0, null, okay. We should have 2 things in the constants block. Okay. So this has an expression now. It is bound to, I don't even know what that is. Something made by the compiler, which is why the line numbers are all jacked. No. Somehow we bound it to U32. I think that this somehow happened in the return type checking, but I'm a little bit at a loss to know why. Now that's weird because it's magical. In some sense, that's magical. It means we don't have to do this second pass because it just has the right thing, and we just somehow, it was magic. I mean, we still have to set the return declaration. However, well, let's... What is return decl? Wait. Did we already get here and then we're getting here again? What's going on? Oh, wait, no. We are getting a little bit stung, not stung. Interestingly, the case we picked was not actually the simplest case. All right, here we passed this to a thing that fixed the return type of the function by matching it to t. Which means we actually baked out that variable. Which means I mean, I don't know. Like I said, if the user does weird bakes and stuff, that's fine too. Here's an even simpler one though. Instead of doing this call where we map it to a function, which we'll bring back in a minute, we're going to say y is square of 5. Right? Okay. Now, we didn't even get all our cowabungas. Like at all? I think this error, I think that's happening because we're polymorphing against the argument and we're saying it's still polymorphic, right? Yeah. Okay. Now the question so we did this polymorph. We're like, hey, there's still unbound variables. I could skip this for a second, because what we could do is say in the special case when this is a quick lambda return, don't do that. Okay, so we're actually not as far as we thought we were, because all the cowabunga stuff we did that was succeeding, we only got to that code path because we had baked out this variable. Not sure what to do here. Not sure what to do here. Let's just see where this happens. So this is the function that's polymorphed off of the other one. Oh. Guys, I didn't notice this. We're stashing off the return type, I think, before we change it. Mm-hmm. 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 So that should move down. Wait, what? We didn't copy the quick Lambda flag? We really didn't. Do we have somewhere the Lambda flags that we copy? Struct flags to copy. Statement flag. Okay. A little bit error prone. A little bit error prone. So that's also a thing. All right. Should infer return cowabunga. But then we didn't say we're back, baby. So we hit this error. Oh. Yeah. Let's go back to the thing that I noticed, which was this. Once we set this lambda, we cannot yield. I'm going to hope that all this returns block checking stuff can happen before, like, this is where it might start getting real messy if there's like tangled dependencies. Yeah. Wait, though. I don't think... we need to do that. This is a little bit hairy. Yep. We have entered the zone of pain. We have entered the zone of pain. Oh, no. Wait, why? I thought I deleted this. Should infer return. Why are we sorting arguments? This is when we're testing the return value, right? Yes. Okay. So this is what I was saying before, is this return statement thinks it is inside a regular old procedure. And I guess we could check the quick Lambda flags. Okay, if this is a quick Lambda, don't type check the return arguments or check names, since those will not exist. I mean, actually not technically true. Okay, this is... kind of bad. This is kind of bad. This is where we've hit a conceptual roadblock. The conceptual roadblock is as follows. It is possible to put as many return statements inside a quick Lambda as you want, if you're being a total weirdo. There are just ways to make that happen, right? Okay. We do want to type check those. Eventually. We do want to type check those. Otherwise, anything could happen, right? However, we don't want to type check them because we want to infer from the one return statement that we really care about. We really do want it to determine the type. All right. However, so we want to check the types, we just don't want to check them yet, right? So what we really want to do is put them in an array of things to check later. And I could actually punt on that for a little bit, but we could say check returns exclamation point. And really all we would be doing is, like, if you somehow snuck an extra return in there, we just make sure it matches. Right, we don't change the type of the quick Lambda based on that. We simply yell at you for getting it wrong. So, but that's ancillary. That could be added here. Okay, so no check-in. Make sure we type check these in post. What a butt pain. Actually, it's not that much of a butt pain because this is going to be a lot more robust than what we did. which was sort of relying on a lot of magic to happen and hand waving. So this is better. It's just sometimes when you make things more robust, they get more explicit and have more if statements and lines of code, which is not the best. If otherwise we do all this checking. Okay. Cowabunga. We're back, baby. It has a Draco Malfoy body. Doesn't have a return value. Really? Really? Did I get that check wrong? Oh, because they're not sorted. They're not, okay. Because this thing is the thing that sorts them. Okay. So that had better be a thing, though. Hey! Okay, we now got a crazy uninitialized value. Why is that? I think it is because we didn't actually... I think we skipped at least a line or two here. It's not only the only problem, but... all right, so we're back, baby. We say, let's get the type. We print it. We bind the constants block entry. Set the type of the return declaration. That actually looks okay to me. That actually looks okay to me. Let's set the dump flag on it so we can see what instructions they are. Oops. Okay, well, we are saying no op and return. Oh, the reason why is because nothing's ever getting into the sorted array. So if we go type check these in post, we would end up sorting the arguments. But yeah, no. So there we go. Well, oh, sorry. No. We don't add the type. Okay. I was looking at that code and I'm like, we're returning the type. Yeah, you don't return the type. Hey, that's our halftime show. Halftime show is we return 25. Oh shit. Oh shit. Hold on. That's why the alarm's going off. It's not halftime alarm. It's the number violation alarm. Because you know 24 is the highest number. All right. 5-minute break. And then we'll be back for part 2. I will allow myself to check chat for a second. I bet you guys didn't know making compilers was so fun. Stretch time? I'm not Summit 1G. All right. As soon as the tea water is ready, though, we will go. Well, we'll let the tea steep. I don't know. 12:42 will be the time. Why is 24 the biggest number? Go on YouTube and search for 24 is the highest number. You can't look the monsters in the eyes, but you can still cross its path. That exists in Fidel Dungeon Rescue. You can play that game on Steam. All right. We'll give it a few more minutes of break and then we will launch into part 2. We will set the 24-minute timer. Can quick lambdas return multiple values? No, because that's not what they do. Maybe at some point we will extend them, but right now there's not even syntax for multiple values. They just do what they do. 1 more minute, and we will go. Go. I mean, really, we should check the map function should make sure it doesn't return any number higher than 24, right? Well, we will not wait for the tea to steep more. We will simply go. Starting the timer. Boom. We'll pour the tea in post. Okay. This is great. We have a square. This will be our first test, and then we'll try the map, and that'll be our second test. Circular dependencies. One of these is square of int, and one is square of u32. Wait, it's U32 for both of them. Oh, no. There we go. Wait, why? This is weird. Okay, here we go. We get the return type. We come on back here. Oh, right. Okay, because in this case... We have three Lambda bakes for some reason. I think one of these is like a header only bake that happens during polymorph, and one is the actual one that we call. So the question is, what are the circular dependencies? Because that sounds bad. And why are we not printing anything? Why does anybody think that this is a good program? All right, we'll just break up my sleep loop. All right. So there's something here in the infer pipe. It's probably our quick lambda if I'm being honest. Oh, there's two things. It's probably because when we didn't no, because we said return type is U32. Okay. So what's going on? The body of this lambda wait. There are two lambda bodies. These are for each of the instances of this thing that got polymorphed. why are we sleeping on the... Okay, so remember we didn't used to... We didn't used to copy the body explicitly, right? We only copied the header, so the body probably... I don't know. Okay, anyway... So what is going on here? We're stuck in pipe infer. We didn't yield on an expression. So what's the problem? Really nothing conspicuous about this at all. It is the body of square that is verified. It is polymorphed from the original. So why... Aha! Okay. Excuse me. It's time to pour the tea. Okay. Let's look at the queued here. The flattened is 0. It's like we're just rejecting it straight out from the pipe. What happens when that body comes up? We throw it back, we throw it back, we throw it back, we throw it back. Really, so my header, why do I not ever see the header? Why is the header not passing infer? Wait, the header is... Okay, yeah, so well, basically if a body is queued as a compilation unit, it expects that it only got there because its header was queued as a compilation unit, but we didn't do that. because of those modifications I was making to make sure that the body was copied. So what do? One thing we could do is we could either not queue the body in this case, or queue the header, or allow the body to not block on the header. Any of those will work. So what is happening? What is happening here? So this queued is right here. It's it in this loop, and queued by line 6904 of typer.cpp. Queue or go. Okay, that's no surprise. So let's figure out why that happens. For this thing. Should queue is set. Oh, if it has a body. I guess we unqueue it later. I don't quite get this part. That should be equal to lambda, which it is. So like we unqueue the header later, but we set highest pipe exited to none. Okay, wait, do we, when we get here, we don't set has been unqueued. Wait, what is going on? Why are you telling me highest pipe exited is none? Let's check that. That is a lie. That is a rank lie. Body header queued. So that's one EDO. Oh, I had it right there. Remember that one EDO. And then, oh wait, it's also, okay, so if we exit, why are we not in a pipe? What is happening? Oh, this is, okay, the bane of my existence ever since I introduced it was the polymorph force infer land situation. And I think that's what's biting us here. Is polymorph force infer. Because this is like this is a header only. It's not supposed to have a queued body. So we should have this lambda. We only really want the type flag, right? Yes, so that's set. So that used to be consistent with has a body. And I could either add a thing here to check that, what did we do before? I think I just want to prevent the body from being queued because that's more efficient as well and causes less of like a data mess in the system. So we're going to try that. It might be a little messy. So what was it in flatten? No, it was in copier. Okay. This thing is sort of the source of the troubles. The trouble with tribbles is happening right here. Okay, we're going to do this slightly differently. Okay, now if I recall correctly, from part 1 of our 24-minute saga, there was one other place where we set where we set we checked it has a body flag. Is that it? Probably wasn't there. Could have been here. That's the flags to copy. It's a white space change. That's our clearing all polymorphism that we have to deal with later. Okay. Must have been in here. Okay, it's this one. Probably 1284. I can't really see it in there, but we probably don't need that now. It's like you don't want to keep accumulating cruft from like things that you tried and didn't need. There we go. There we go. Let's not accidentally revert our 24 minutes of work. Okay. So GG's. Let's do fun. Let's have fun. Funsies. results is map results square, right? Print results is whatever. Okay. Why don't we do something really for sillies? Compose F G actually to R. This isn't going to use a quick lambda though, because you can't really pass quick lambdas into this. Actually, maybe you almost can. Maybe I should make that work. Anyway, we could write a compose function, but let's not do it because it's not about quick lambdas. So this very basic thing works. Now there's some no check-ins that we made. We're still not type checking weird return values. We should make a repro for that breaks and then fix it. But first, let's see if we pass tests, right? We probably don't. We probably fail some kind of test, just like life. Just like life. Now, most of these tests probably don't use that many quick lambdas, or a lot of them probably don't use any. A lot of them would probably only use one incidentally. There's a fail. Wait, 050 this failed? That doesn't use quick lambdas. This quick lambda has a malformed body. Oh, because we don't always make a return statement. Okay, here's what we're going to do. Okay, we forgot this part. If it's a block, then it's allowed to be void, right? So funny because we just wrote this code last night. It's allowed to be void in the case of a block. I guess that goes to show you that literally no test uses this formulation right now. Sokoban might. We don't do a lot of quick lambdas in Sokoban either. Anyway. Malformed body. We could not find its return statement. Okay. If it's a block, that's okay too. That is okay too. Okay. Good thing there's a leaf weed whacker dude out there now for all the people to hear. What about this? Asked return. I mean, like we only need to do this if it's not a block. So like all this stuff is only when we know the return type is not necessarily void. Okay. Do a bunch of stuff that involves figuring out the type of our return expression, but if asked block that type is void, and we don't need to do any of it. If we don't, in which case we just fall through to the below if statement. Okay, warning, do not combine this with the above if statement since the flag value may change. Okay, so what we're going to do is grab all this stuff okay, and we're going to go actually, you know what? Forget about it. Forget about it. Forget about it. Let's just do this. Wait, what just happened? Okay, no, this is fine. This is fine. Okay, great. Something like that. Let's test here again. I messed it up. I somehow made the void. Okay. Somehow, for this example case, we're triggering that if, or I just messed it up. For this one, it's still got a Malfoy. What? Bro. If it's a return, I mean, what? Problem is, see, because Visual Studio frickin' sucks ergonomically. I have to go change. Like there isn't just a drop down of what we're running right now. I have to do this and this. I mean, I guess. Yeah, no, this is a 1990 user interface. Okay. What is going on? How does that happen? I guess we don't. This is a little bit of a messy thing to do anyway. You know, okay, there's a kill two birds with one stone thing here, two very small birds, but if we store the return expression, the return statement, we don't have to search for it. We know what to copy, and so like the thing about doing this block was I was like, well, this means people aren't going to like flatten it out or whatever, but you might do that. Like somehow usings might go in. Like it's just searching the block like this is not really the way, honestly. So let's do that. Let's go. We're going to add a thing here. That's great. Great. Okay. Our deduplication probably, we're generating too much code. All right. So ask return quick Lambda return statement. Okay. Okay. We need to check when you submit one of these as an asked. We'll do the searching of the asked at that time, but that's at the time when we're validating your input. So doing a bunch of asked searching is totally reasonable. Or is it? I mean, I feel like we should do this during infer is the problem. Which is sort of like where we're doing it already. Except no, we don't. I just don't want to be in the business of doing this kind of thing here. You know, I think eventually we're going to make quick Lambda its own ask node. That's like sort of the only reasonable thing to do. Sort of. Maybe not. Maybe that adds complexity. Okay. Yeah, you know, it's crank session, but I'm cranking internally in the mind instead of on the keyboard because it's like, do I want to do this? Does it make sense? I think the answer is yes. Because even if you submit something weird in the asked, let's even go expression. Problem is we have to make sure to link that in the copier. But if we do that, then we don't have to check the type in the block. Let's, before we just dive in, oh man, I didn't want to recompile, guys. Just run sometimes, please. I fucking hate this program. All right. What even is happening? Okay. Malformed body. We don't have that breakpoint anymore. Oh, wait. No, this is... No, that is. Okay. So, I guess... Oh, like we put a return on, yeah. So really what I'm saying is I really want basically everything that we used to do. There's a procedure call, an if, and a block. Where is this? So I see. This is redundant. Okay. So what really the quick Lambda policy is we auto-generate a return statement, but if I guess you could have a quick Lambda with multiple values. If you put a return statement, and we probably want to check that actually. The problems are piling up. Dang it. Okay. I poured some tea on my note paper, and then I tried to yank it out of the notebook, and it broke. Okay, we're cranking. So, let's look at the caller. Yeah, we do a different thing. Yeah, okay. So for now, we're just gonna, like, we do this in order to, like, not create an extra block. I'm not, and that's why the other checks we were doing weren't working, right? Because they were assuming that if there was a block, it would be one statement in the top, and it's not, because we're just parsing into the block. You know what? We could just set a flag on the quick Lambda in this case rather than search. That would be cleaner. That would make me happier. Let's do that. So this is the current. We're still going to have to, like, ast validate something about this, but we're going to go Lambda flags or equals in block form. Wow, we're running out of flags. All right. So we're just going to set that. All right. So in finish quick Lambda, we're actually going to check the block form flag. Okay. So we just do that. Okay. I'm just going to clean this up, like, right may be null. Okay, we're parsing the expression. If it's not correct, we're asserting the error may be that has been reported. We do finish quick Lambda. Okay, and then in finish quick Lambda, let's put this in make quick Lambda as opposed to finish. There we go. Okay, so now this flag is going to tell us what to do. Oh, hey, remember what I said about when adding new flags, by the way. Tra-la-la-la-la-la-la-la-la. Tra-la-la-la-la. All right. So when we're doing the type check, instead of doing all this, what's the statement or whatever, we're going to go we're going to do this. Hold on, that's the wrong thing though. We want not the return declaration. We want this part. Okay. The asked return. There, we delete the block part. We do this. We do this. Quick Lambda has a malformed body. Okay. Okay. I feel like I'm still forgetting things, but wait, finish Quick Lambda. Oh, yes. Because right may be... Oh, yeah, never mind. Okay. I get you. It can't be null because we copy the location off this expression for other things, because when we do error reporting and stuff, etc. And okay, so anyway, I was thinking we just wouldn't pass the block here, but we do use it. Okay. Lambda ends in arrow void and is not C call. Oh, right. Because we are actually... Oh, guys, for this form of Quick Lambda, we literally don't need to do any work, because it doesn't return anything. So like even here, this return declaration, like literally none of this has to happen. All the fancy new things that we did. Okay. Which means literally all this doesn't have to happen. Like literally all of it. Hold on. Because all we're doing here is we're inferring the return type, which is not necessary in this case. There we go. There we go. Now what about this one? We're also saying arrow to void. That is not good. We're saying the return type is void. Why are we saying that? I broke that somehow. The return type is void. We shouldn't be here at all. Okay. Yeah, I need to simplify this back out. Because literally, we should always have an asked return. Okay, so we're cutting this off again. We're doing that. We're complaining about people's malformed bodies. And this should not be a thing. And this should not be a thing. Got a redeclaration. Okay, right, because this was only in the, yeah. Okay, that's fixed. And that's fixed at simultaneously. It's like the particle going through the double slit experiment. That was a kind of a mess to do a simple thing. That's how it is sometimes. Sure is a lot of cowabungas happening. Okay. Well. Substantial changes to the way quick lambdas get their types inferred. Fixing some bugs and increasing general robustness. General robustness, team member of G.I. Joe. Okay. Now we're not done. We got a bunch of stuff. We left a trail of tears that must be addressed before we can check this in. We've got some no check-ins. Some of them are just comments of old code. So let's start deleting these. Like, bam. It's funny because we ended up with like almost the same thing. All right, let's just do this. Okay, and then we do that. Now, oh, the real, actually, before we go start hunting down the rest of the no check-ins, the real test is to go back to this thing that was crashing us, right? And see if we actually do that correctly, which we may not. Like the thing that we fixed, like literally may not even have fixed this. Like I did a re-implementation with an eye to decreasing things like this, but did it actually fix this? Undeclared identifier test array. Wait, what? Oh, because I deleted some things from this file. So firstly, yeah, like what? And then float, I guess. No, I destroyed the dude's test. Hold on. Let's just, rather than hypothesizing about what the test was, I'll go get it out of the mailbag again. Oh my God, I got so much email since even just starting. Bro, also 3 new bug reports. Okay. We might have a bug snacks from the mailbag stream later tonight. This one. All right. So I'm just recopying the test case that was submitted by the people. It is this. And I wanted to rename these types. This is where that apple, because it's called tea and that's confusing. So I'm going to do apple and banana. All right. So because there's T's up here, and when you're looking through the debugger and seeing the stuff, it's like not helpful. Okay. So here's the quick lambda down here. And the question is, what is going to happen? Dang it. Okay. This is actually the same problem that we had before. However, we should be in much more of a robust place to attack it. Because like what was happening last night when we tried to fix this is I got caught in this bind having to do with like the way quick lambda was implemented, which is why I wanted to go do this more robust thing. So now I have to go debug the original problem. And actually, let's not even do that. You know what? Since we know this isn't fixed yet, let's finish cleaning up the new implementation of quick lambda, which is, as far as we could tell, is no worse than the old one, because it works for everything that already worked. And then we'll debug this separately, because like this is a lot of code that we changed. I don't want to keep chopping it up to try and debug this thing and do something irreversible when what we have is like pretty okay. So I'm going to get rid of the debug dumps and the cowabungas. What is this even doing? Whoops. What is this even doing now? So return decal type inst type valued expression. We get the type of that. But we're not actually doing anything with it anymore. So this is fine. That constant represents what we want to return. Else, that constant represents something else. So so let's avoid trying to poke the value into it. Something like that. Okay. We get rid of this cowabunga. Oh, nope. Because this will cause us to set it to I mean, this is stupid, but maybe we'll find a more economical way of saying this. Okay. Something like that. I broke it. See, this is why you check in before you start doing stuff like this. What? What did I break? I think that. Okay, something I don't get is happening here. We need to the whole reason we're checking this last unbound constant is to make sure it's the one we think it is. Nah. Whoops. Okay. So I'm confused because it does appear to be pointing to the right thing. Oh, you know what? Maybe it's in the wrong scope. I bet it is. Okay, this is a thing that I didn't totally expect. It's a little, okay. So this defines constants block entry is a field that we set on polymorph variables when it's a type that we create for them when they're things that need to be filled in, and we look for that later to know that those are things that need to be filled in. Now, I guess we just copy those verbatim. When we copy the procedure because we're polymorphing it. So they no longer point into our block. Okay. So okay, that is not the situation. So string compare, ugh. This shouldn't happen yet. See, we had code that appeared to be working, but it wasn't quite working, right? And when you get a whiff of that, you have to chase it down. Otherwise, it just hides in your program and you have this extra complexity of like things that don't quite do what you think they do, and that's not good. All right, so I got the number of spaces right. Lol. That was just winging it right there. That's some expert text editing. I'm running out of fuel, guys. Bad news. Oh no, it's the last three. The last three little nuggets. Assert false. Oh. Paste pasta. Pasta. Okay. Okay. Still so many things we need to do. Let's continue eliminating the scourge of the no check-ins, except for this one. This one is one I'm keeping around for totally different purposes. But all this stuff, okay, good. We didn't have to make flatten more complicated. That's good. That's something we're going to have to figure out. You know, we never set that, so we're going to rebuild without that. Do this by type checking the return. We're not going to no check in that. We're not going to no check in that yet. And we'll get rid of this. Oh, come on, God. Why does anyone think this program is good? Okay, this one, this may still be an issue. This we have written down on a piece of paper. We'll make a tag for it. Okay, so that stays. This one, I can't read anything in this program. I think we can fix this error message. Right, so this is going to cause us it's going to cause us to give an error message again, right? Attempt to define. So that means, okay, I deleted that no check-in, I guess. No, we just couldn't see it. From merely April of this year came that comment, and now it is no more. Okay. So the only thing that scares me now is this one. Okay, wait. Let's redo the search. There's one no check-in to get rid of. It's this one. And I feel like this is going to fire. And then we get to figure out what to do about that. I feel like that's going to stop us here. Yep. Okay. Um, if it's a quick lambda, you know what we could do? We could just put a flag on the definer. Like, that's a little bit messy, but it's very easy to go remove isolated things like that later, rather than putting a bunch of weird code here about accepting certain things. So if we put a flag on this that says, this declaration is the quick lambda auto declaration, then that helps us here. It also helps us that other place where we were doing all that crap to, like, you know, that crap we did about string matching? Or no, not that part. The string matching crap still has to be there. But the part about the number of declarations and all that, we can remove that and just look for the one that's flagged. Or if more than one is flagged, then that's an okay. So it ends up looking a little bit similar, but actually is tighter constrained and more robust, I think. Yeah, let's see. Quick lambda return. Okay, so let's use a high flag. Less valuable real estate declaration is quick lambda return type. Okay, we're just going to flag that when we auto-generate it. Does that even return what we added? Yes, it does. Okay. We actually set the enclosing scope. We don't set the identifiers enclosing scope. Okay. Great. And then in this particular check in polymorph where we say is needed but was not specified. Okay. We go okay. Now okay, I think we copy all declaration flags, so that should be okay. That should solve that problem. And then assuming that that happened, we can go use it to clean up the other thing. Okay. Wonderful. Wonderful. Let's go back at this and try like version 7 of this frickin' function. We wrote all this today. And this is why we'll be canceled. It's because we talk about malformed bodies. So when we go through and do this, we say if it doesn't have this flag, we ignore it. Okay. If there's an unbound constants block binding, and it's that, we set it. Okay. Really, this is completely illegal now. Okay. So that means this part just becomes this. You know, we don't even need to check this now, because all of this code was here to check the case in which this wasn't really a return statement, but like it is, because we flagged it. So like this is really not necessary, all this stuff that we wrote. GG's. Okay. So then we get rid of this. We get rid of this because of course we should. I think. Wait. We don't need to infer the return. If there's no unbound constant. Like I mean, this is dangerous what we're doing here, but I think we just do this. That got shorter. Scope entry, biggest mistake in the compiler. Biggest mistake. I screwed it up. Guys, I screwed it up. I knew it was dangerous to delete that code. We don't have much time till the 24 alarm goes off. Okay, what's going on? Still polymorphic. Why? Why? What did I do? I broke it. I broke it. Last unbound constant. We didn't complain. Last unbound constant 0. Is it because it's not getting copied? Mm-mm. Mm-mm. All right, hold on. Hold on. Takes so long just to click on the thing. All right. What is going on? Declaration flags. Wait, it got defined somehow. Dang it, guys. Okay, hold on. Let's actually rewind for a second. We're drinking the back in time potion. Okay, we're going to have to remember that. That's a lot of typing. So this thing, like, we're just gonna run it back. We're just gonna run it. We're gonna take smaller structural steps. Okay. Smaller structural steps. Okay, that's fine. That's actually fine. Because we do this. Okay. Now maybe this already hoses us without doing the rest of that stuff. Oh, see this. See, I deleted the stuff about last unbound constant. It's null here. What did it say? I don't want to have to go back in the VOD. See, this is weird because we're deciding what it is, and then it's going back and getting changed on the next pass, which is weird. And our 24 minutes are up. So we're very close to being able to check this in. I had wanted to get it in the last few minutes. We're very close to being able to check it in. I just hosed something at the last minute. But we can go say hello to chat. The official crank time is over, but we're going to continue until we actually finish this problem. How's it going, everybody? So that was pretty productive. We are just about done with the main refactor. And then, as I said, there's some side stuff that we have to do, such as, for example, stashing return values and type checking them later. But that was stuff that we weren't doing before either. So that was like lack of robustness that was already in this feature that we're going to make up for. But yeah, let me, I'm going to take a few minutes of break again, maybe make another tea, and then I'll just debug this. I will just debug this. Debuge. But see, that's like, it's kind of amazing that for as long as I've been working on this compiler, it's been kept simple enough that in like 3 hours, I could go change the entire way a major feature like this works. Not the entire way, but large parts of it. Like that's pretty good. And we had it working, and then I broke it at the end, right? So it shouldn't be hard to fix. But yeah, I mean, that's pretty great that we were able to do that in that short amount of time. All right, I'm going to warm up some tea. Are there any questions about what specifically we did during the crank time to the code, about how it worked and all that? You joined from RAID. What feature? If you want a longer explanation, you can go look back in the VOD, but we have this quick Lambda feature, which is a way of defining functions that look like they come from one of these looser, non-statically typed languages, but then gets inferred into a strongly typed thing. And there's just some things about that feature was put in a long time ago. And there's some things about it that I always knew were a little bit janky and not robust. And but back then it was like, let's just get the compiler going and working and figure out how everything goes. And then we can re-implement things if they're not robust enough, right? So it came time to re-implement this. So that's what we've been doing. That is what we have been doing. Any other specific questions about what we did here? Nobody has any questions. Okay. Why do I do this? Are there any advantages apart from having to type less? Not really. It's just typing less. Actually, yes, there is an advantage, which is that normally a procedure's return type does not get inferred from its own body, because that's like a backward inference that we don't normally do. In this case, we allow it to happen. But like, yeah, so the only way to infer a return type from a procedure body is this way. Will a recursive quick lambda using this work if the this is a last call? What do you mean by a last call? I mean, it should work. There's nothing about this that is specific to any type of function, so it should work fine. Will most of this hold when you add captures? Probably. I'm actually not sure if it makes sense to have captures with quick lambda, but it might. We'll see. You don't know the return type if you do x to this of x? Yeah, you do. Oh, I see what you're saying. I see what you're saying. Yeah, we might have to disallow that. We'll see. I have people in chat repeatedly, annoyingly asking me to call square with foo when we can't call square with anything right now. Thanks, guys. I mean, I could have shown you that in the middle of the crank, but not right now. This error that you see on the screen means we cannot call square at all right now because I just broke it in the last 10 minutes of the thing. And we are now about to attempt to unbreak it. Let's just assert that we always see one of these. And this is just like keeping a baseline, making sure we understand what is happening. Okay. So it does go down to 0 here for some reason. These peanuts are really good. I do not use Visual Studio Code at all, guys. I do not run the program known as Visual Studio Code. How many calories? 1,700 calories in this can. $1,700. Visual Studio Code is IDE slow bus, guys. Okay. How they made bracket colorization faster. I mean, okay, guys, here's the thing. I mean, I skimmed through that whole report But like coloring brackets based on their exact nesting depth is not even very good. Like I wouldn't want that anyway. Like what I want to know is that the bracket that I just typed matches what I think it does. You know, which is like, anyway. Anyway. But you'll note, okay, guys, you'll note that in the process of making that syntax highlighting reasonable, they had to like build it into the editor, right? So all this rhetoric about how the language server protocol is good and like extension languages are good and scripting, they undid all that shit to make a single relatively trivial task fast enough to be usable, right? So keep that in mind next time somebody argues for that stuff. They themselves did that. Okay. What is going on here? Why? What is happening? It's like we're back to this early version of something that was happening in the first hour. I mean, we could collapse that later. Let's do this. I'm just jamming at this point. I'm not trying to recover from the previous stable state. So the other thing confusing it is, I don't know. I mean, let's just comment that I don't think we're getting to that, but let's just make sure. So last unbound constant is set. We're at BEC. Wait, this is polymorphic. Oh. Guys, I forgot part of it. That's what happened. Okay. So initially, part of the job was if there are any unbound parameters that are not returns, don't try to do the rest of this stuff. And I forgot that part at the end when I was restructuring. Let's do this. Num unbound argument types. Num unbound return types. And last unbound return type. Okay. Okay. Let's just do this. Let's just do this. Okay. So if it's unbound and it's a return type, otherwise it's an argument type. I think this is the thing. This was sort of stealth in the code. It was obvious when I first wrote it, but even over the course of that 3 hours, it became more stealth. Okay. So if there are no unbound argument types, we do all this stuff. Right? Otherwise, that's where we set this thing to polyuse. I mean, maybe this is going to be harder to read due to the extreme nesting, but wait, is that in the right place? Yeah. So there was all this matching stuff that we changed that we don't even need anymore. I don't think, but oh yeah, last unbound constant is not what it's called. Yeah, like I think we checked this and yeah. I think that check was sort of ended up bringing us here before. So we're going to get rid of otherwise set to polyuse. We're going to get rid of should infer return. Right, do we check this? No. We'll see if that goes on. Let's get rid of this. I think we want to move this out. All right, we'll put that back. Okay, let's bring back the square. Okay, we rescued it. All right, for the person who wanted me to call square on hello, here you go. I hope you appreciate my ability to call square on hello. What about foo? I don't know if we could do foo. Foo is too hard. Hello, we could manage. Foo is maybe a bridge too far, guys. Okay. Okay. Let's go back here for a second because I feel like some more stuff could be cleaned out. So all this matching stuff here was like to make sure that this wasn't an argument declaration, which we now know that it's not, right? So like, I think basically all of this goes away, right? Pretty sure all of that goes away. No. Oh, wait. Plus author. Dreamweaver. Plus author. Plus actor. No, plus actor. Sorry. Okay. Look at all this code we wrote today that we're deleting. That's great. That's great. That's great. That's great. Wow, that's so much less code. Okay. Do we check in? I think we just about check in. We got to run all the tests and stuff. I've got a list of like other to-do things. Some of them may go pretty fast. But I think it would be break time first. Got to have a break time. Let's run all the tests. Okay. That appears to be done. Well, let's commit it. Let's make sure we update. Oh, someone else made a change. We're going to commit. Substantial refactor of the quick Lambda implementation still needs me to do some robustness stuff around the edges. But there we go. I just wanted to wake up this morning. I got up. I paid some freaking bills because that's what you do when you run a company. And then I wanted to get on and do a crank session because we hadn't done one in a while. So we successfully cranked on this reimplementation. Now, as I mentioned, so there is more stuff that has to be done, like if somebody sneaks a return statement in there, which there are ways to do. We have to actually type check those. B, there's just a couple little things that we noticed that we want to like clean up and stuff. C, we saw like a map example that was asserting in debug, which isn't good. That's not a user visible thing. It was like asserting after reporting errors, which is just, it happens sometimes if we don't exit the current code path after generating an error, like we think it's okay. So there's little things like that. We want to write a how-to about quick lambdas because that's not even a thing right now. I don't think. Like in the how-to folder, how many funky arrows even are there? There's only 2. So this is a completely undocumented feature that the people don't even know about. And so we're going to want to come on tonight and tell the people about that. And I'm going to try to think about how to do that return statement type checking without it being completely disgusting. to do that in the opposite order. The people deserve to know. I agree. The people do deserve to know. Well, okay, let's face it. Some of the people deserve to know. And not all the people actually deserve to know, right? Like some of them I'm fine with not knowing. Okay. Since we were nice, we got raided by at least 2 people today. So let's see who we could pass the raid on to. In the, what is the category now? It's software and game development. How does that even work? I'll go to my channel and follow the link to the category because that's that's me. That's me. We should do a whole stream where I just echo like that for the whole stream. That would be fun. That would be fun. Okay. Who can we send the people to? Battle boats with buddies, React Native, and Svelte Native. Okay, we've rated Retro MMO before. I think we've rated Worm Juice Dev before. I'm not sure though. Have we rated Worm Juice Dev before? Pomodoro. Lol. They're keeping each other accountable for working up to 15 minutes at a time without a break. Okay. Sorry. No, whatever works for you, it's great. Okay. Pocket, well, we could send it back to Andy. Let's see. we've rated Andy a bunch, but why can't, it's the year 2021. I can't see where the highlight is. There it is. What's he got going on?
You want to have a separate one called Spawn?
Milliseconds T. G-Loot. Glute. Okay. Rating Andy is a good possibility. Custom engine, not that many people do that these days. Let's just see if there's somebody with like 2 viewers. Not really. Not really. There is no Tim Bodette on this channel. There is no Dan Bosker on this channel. Why are you guys telling me about people who don't exist? Partial evaluation with normalization by evaluation. That sounds so exciting. Underwater exploration prototype in Unity.
Also, I see that this rigid body.
All right, let's do this. I hope he has something impressive to show you. All right. Thanks, everybody, for coming by. And I'll see you later.